Hi, my name is Charles Kaplan. I'm a professor at the State University of New York at Old Westbury, and this is the fifth video on the chain rule. Um, let's see. So we have a problem. There are four other videos prior to this. You could take a look at them. The video just prior to this has some trig problems in it, and we're going to do some trig problem differentiations after I finish this primary problem here. So this is, as it turns out, is a chain rule problem wrapped around a quotient rule. So let's review the quotient rule. So we have two functions, f of x over g of x. We want to differentiate this. So we're going to take the derivative of the numerator and multiply it by the denominator. And then we're going to subtract off the derivative of the denominator times the numerator, and we're going to divide this whole thing by the denominator squared. So there's the quotient rule. We take the derivative of the numerator and multiply it by the denominator. We subtract off the derivative of the numerator times the derivative of the denominator times the numerator, and we divide the whole thing by the denominator squared. In fact, in this case, where we have x plus 5 over x squared plus 2, let's just do that right now because we're going to have to do it in a moment anyway. So I might as well do that now. We have, let's call this h of x is equal to x plus 5 over x squared plus 2. And it's a little bit big. This is an exponent, not... Okay, so we're going to take the derivative of the numerator, which is 1, times the denominator, which is x squared plus 2. You know, I need to get this marker is, I think this one's a little bit better. So it's the derivative of the numerator, which is 1 times the denominator, minus, oh yeah, this is much better, the derivative of the denominator. Well, the derivative of x squared plus 2 is 2x, times the numerator, x plus 5, and that's over the denominator squared, which is x squared plus 2 squared. So, let's see what we've got here now. Let me move this up. So, h prime x is equal to, well, this is x squared plus 2 minus, well, minus 2x, well, 2x times x is minus 2x squared, minus 2x times 5 is minus 10x, and that's all over x squared plus 2 squared. I need another piece of paper here. I have run out of room at the bottom of that page. So, let's straighten this out. H prime of x is equal to, well, let's see, x squared minus 2x squared is minus 1x squared, minus 10x, plus 2, all over x squared plus 2 squared. And I don't like to lead this off with a negative sign, so I'm just going to rewrite this as h prime x is equal to 2 minus 10x minus x squared over x squared plus 2 squared. So this is the derivative of, let's see if I can find it. Here it is. So, this is the derivative of the quotient in the original problem. Okay? So now we just made life easy for ourselves. F prime x here is equal to 2 times this whole thing. This becomes 2 minus 1 or 1. I wouldn't ordinarily write it in, but I am here just for purposes of clarity. And then we're going to multiply this by the derivative of the inside portion, the quotient. And if you recall, that was this right here. So we're going to multiply it by, let's see, can I get this all in here? Let's try. We're going to multiply it by 2 minus 10x minus x squared over x squared plus 2 squared. So I got that to fit. Okay. So this problem isn't too bad. Now, what shall I do? I didn't work this problem out before. Most of these I don't work out. I kind of do them on the fly. I hate doing extra work. Okay, so f prime of x is equal to, well, this is 2 times x plus 5 over x squared plus 2. And we're multiplying it by 2 minus 10x minus x squared all over x squared plus 2 squared. Well, I can see we have x squared plus 2 squared times x squared plus 2, so this is going to turn out in the denominator to be x squared plus 2 cubed. And in the numerator, it is a complete and total mess, but I don't think we're going to be able to do anything with it. So we're going to have 2 times x plus 5 times 2 minus 10x minus x squared all over x squared plus 2 cubed. Now I'm looking at this thing, and quite frankly, I don't see where, I can expand, I can distribute the 2 and make this 2x plus 10 times this. But we're not going to gain anything else, so we can do, this answer is perfectly acceptable. If you wanted to, you could do this. You could make it 2x plus 10 times 2 minus 10 minus x squared all over x squared plus 2 cubed. This is also a perfectly acceptable answer. However, I personally would have just left it in this form right here. I don't think I would have bothered to do this, but either way, this is it. Okay, so let's move on to some trig problems. And if you look at the prior, wow, I got a lot of ink spots there. If you look at the prior video I did, you'll see that I wrote out the derivatives for the 6 primary trig functions. I'll do it again. d dx sine theta is cosine theta. The derivative of cosine theta is negative sine theta. The derivative of tangent theta is secant squared theta. The derivative of secant theta is secant theta tan theta the derivative of cosecant theta is negative cosecant theta cotangent theta. Oops, sorry about that. That was right on the cusp. So the derivative of cosecant is negative cosecant times cotangent. And the derivative of cotangent theta is negative cosecant squared theta. Okay? So those are the 6 primary trig functions. We'll cover, in fact, I do cover inverse trig functions and the differentiation of them in a separate video. So let's work a chain rule problem using trig functions. How about y equals secant x squared? So the derivative of secant is secant theta tan theta. So y prime is equal to, we're just going to repeat the x squared. That's our theta, okay? X squared equals theta. So secant x squared and then that's multiplied by tangent x squared, and then we're going to multiply it by the derivative of x squared, which is 2x. So y prime is equal to 2x times secant x squared tangent x squared. There's the first derivative of secant x squared. So let's work one more. Nope, we can't. This is Charles Kaplan. I'm a professor at the State University of New York at Old Westbury. We've run out of time. This is the 5th video on the chain rule. I think I'm going to do one more, make a 6th video out of this, the chain rule, with some more trig function problems. In the meantime, I hope you found this video helpful. Check out the other videos that are up there. Good night.